So about 6 months ago, I was in the offices of one of the world's largest banks running a workshop. And in this room, we have the VP, we have a couple directors from operations, from product, from engineering, and a few of their ICs. And so we're in this room, we're doing this workshop, and the purpose of this workshop is to really draw out the deployment and software delivery pains and bottlenecks that they have. And while I'm sitting there, I always start off with this question, and I asked them this really simple question, and none of them had an answer for it. And to be fair, they all had an answer, but the arguments and the disagreements that ensued directly afterwards made me realize that none of them knew like the real answer. And it was a really simple question, which is, what does your CICD process look like? And because we had the VP and the directors and the ICs, they all literally described and were kind of yelling at each other about what the process actually looked like. And you know, this is a pretty normal situation when we do these workshops. And we go in and we ask them a few questions, they argue for a bit, and then we kind of stop them and we go through the process together. And I asked them, all right, well, let's just start with just the simplest thing that we can agree with, and this is what they put up. Of course, going to production from coding into production is a lot more complex than this, but this is typically what we start with and is a great place to start agreeing on. As I start to ask more questions about what's actually involved with your software delivery practice, it turns out that there are people involved with this. It's not just machines talking to other machines. So we add dev approval and a QA approval into the process. We add integration tests. And then we also start to understand exactly what was the previous system. In this case, it's Git. And what was it doing to trigger this pipeline? So we're getting to a little bit more complexity and sophistication and understanding exactly how this software delivery process goes. As I start to dig in more, it turns out actually product management is part of the approval process. QA is there again. You can see that after the integration test of stage. So QA approves it twice. There's an operations approval that comes into place. They go and update Jira. And then they, for some reason or other, they just wait for Tuesday, because Tuesday is when they do their deployments. When I asked them why Tuesday, they literally said that's just the day that we do it. And what I assumed was that there was a person in there that decided Tuesday was the day. That person left years ago, and they just kept going with it, just following their standard process. They update Jira, of course, for some sort of compliance reason, so I think that's good. The other interesting thing is not all of them understood exactly how code gets into production. Everybody had a particular piece of the puzzle. So this little part wasn't even compiled by one person. It was everybody from their respective departments trying to piece this together. And I'm sure that this has happened to all of you where because this process is not codified anywhere, it's codified in our heads. That moment that one developer who coded it up leaves, that knowledge leaves with them. And so being able to just get this part together is practically impossible. We're at this point really just guessing at what actually needs to happen and how it happens. Let's see, what else is in this picture that we can draw out? You know, the QA approval before it runs into stage was also something that they even disagreed about when QA was involved. When does QA actually reject a build? So it takes a lot just to get to this, which if you are in a room with a bunch of executives and ICs and developers, and they can't tell you exactly how this happens, how are they going to improve this process? How are they going to get better at this if they don't really even know what's there and what's breaking, and they can't even disagree on what's wrong? So what starts off as something as simple as, oh, we have deployments down. We just use a shell script and we get it up into production. Jenkins helps us do this and we just deploy. Actually looks more like this. Go talk to your manager. Make sure that he or she is approving. Go get a product approval. See if they care about what goes into production or not. Get a security scan. That's pretty standard. And then lastly, just update Jira. Make sure that that ticket is updated. And all of this, if you're lucky, you have scripts to do this. right? In most cases, it's a human process that is encoded inside of them. They know that I got to go update the Jira ticket. So this is actually like your best case scenario when we run into these situations. So this is what the actual workshop looks like. We use sticky notes because, again, remember, none of them know exactly how this process works. And sticky notes allow us to move things around, right? So when an engineer puts something up and another engineer disagrees, allows them to easily move it. So we erase the lines and we draw new lines. Or when we need to really dive into a particular box or a sticky, we can kind of take that sticky off and break it down into more boxes. The interesting thing about this is that they said, well, we just deploy into prod, and that's what we do. After asking a few questions, I think you could probably see it on the right-hand side. They have a HIPAA environment. They have an environment in AWS. They have an environment in GCP. And they have an on-prem Kubernetes environment. So it's so complex that they just kind of wrapped it up. Oh, we just deployed a prod. In reality, getting your code into those environments is very, very complex just for production, let alone stage and dev, and going from that beginning to the end. The other thing that we do here is we actually don't let anybody talk when we do this. So we do this in silence. And we do this because if you didn't do that and you let the VP talk, he will or she will talk the most. Which is pretty standard. Executives love talking and hearing themselves talk, and they clearly think they're right because they love to talk so much. But in reality, what happens is they know nothing about how code gets in production. They know nothing about the pain that developers have. They know nothing about the bottlenecks, and yet they're the ones making decisions. And so when we have everybody be silent and do this collaboratively, what happens is the people who are more quiet and more submissive or subversive, they are actually participating in designing the reality of what's actually taking to go to prod. When you let the VP talk, he'll tell you that, no, everything is fine, everything is rosy. There's nothing to be fixed here. And so what's great is like everybody's collaborating and putting things together onto the board, drawing lines without using words at all. And we get to the truth of what it takes to get something into production, and we get to the truth of where the bottlenecks are. And for the very first time, the VP or the CTO gets to see the pain that the developers have been dealing with this entire time. So here's a few more pictures. Again, some more drawing. We ran out of stickies, so we ended up just drawing on the board, drawing lines, everybody collaborating together. And this is what the final diagram looks like, and even this is too abstract, because if you look at the box for deployment into production, it goes deployment into AWS, GCP, and HIPAA. The reality is that box is very, very complex. It probably would take up a whole nother screen, because the way that we do deployments is it's a multi-region deployment into multi-clouds, multiple environments, databases, multiple languages being deployed in production. So that box alone is a whole nother screen and set of complexity. And it's important to understand all of the complexities that are taken into account when you move into production. And they have to be codified somewhere, because today, right, before I had walked into that office, right, and most of you are customers of this bank, they had no idea really how things went into production. It was all in people's heads. So we're finally getting out of people's heads and at least getting it into this diagram. And this is what Spinnaker sets out to solve. Most people probably think of Spinnaker as a CD tool and a deployment tool. And it does that really, really, really well. But over the years, what it's transformed to do is really be a software delivery platform. And us being here at Delivery Conf have probably heard that deployments are just a part of the entire life cycle. Right? So Spinnaker is a platform that will get you 80 to 90% of the way there to encompass your SDLC and ask you to participate in the last 10%, because it is a platform to build in what is custom for your environments, what is custom for your custom companies, what do they need. So it's different than just a deployment tool. So a little bit about Spinnaker. We have a very active community. We have had 400 contributors. This is actually kind of a little bit old, so it's more than this. Over 400 contributors from the world's top clouds, so GCP, Azure, AWS, Oracle's now participating, Netflix, of course, and a bunch of other great companies. We get about 100 commits a day, and the community is growing 100% year over year. It's used across hundreds of enterprises like Airbnb, Sony, SAP, Box, MuleSoft, Target. So We are using it at really, really big scale. Some of Amazon's and Google's biggest customers are using Spinnaker to deploy. And this is what makes Spinnaker and Jenkins awesome. So you have the goodness of Jenkins. I'm sure many of you are using Jenkins today to be able to do software deployments. And what I'm going to show you next and what you came here to see is how Spinnaker can add to that. It's not an either or, it's not a Jenkins versus Spinnaker, but it's a Jenkins and Spinnaker. And together we really make deployments really awesome and safe and enjoyable because in the last kind of workshop that we do, that is an anxiety-inducing process that nobody knows how things get into production. And I'm sure we've all been part of production deployments that your heart is racing and you don't know whether it's going to go good or bad. Right? And so a lot of the orchestration is tied up in Jenkins. Spinnaker can add to that psychological safety, and I'll show you how. Before we get into Spinnaker too much, I want to define some of the terminology, which is a little bit different coming from a Jenkins world. So when we talk about an application, it's typically a microservice, right? In a lot of other cases, the way that people deploy an application or define an application is a composition of multiple microservices. But in our world, in the world of Spinnaker, an application is a microservice that's independent of anything else. A pipeline is a workflow of triggers, one or multiple triggers, and multiple stages, right? Again, defining that workflow from beginning to end. A trigger is an automated way to kick off the pipeline. So think of something like Git, or you push a Docker image, or even you push a message into a PubSub queue. And the last one is stages, which is really, really important. This is different than the way that Jenkins defines their stages. Our stages are predefined actions, and they don't require you to write any code in order to get that action done. So it's very declarative. You're defining your outcome. So for example, it's a checkbox to say you want a blue-green. It's not, here's a place for you to code up your blue-green. So you essentially set the mode to the way that you want to deploy to blue-green. And Spinnaker will handle this behind the scenes. And we do this for every stage. For every stage that maybe you want to increase your replica set size or your auto-scaling group size. That's a stage. You tell it, here's where it is today, and you grow it by X%. Spinnaker will handle everything behind the scenes to make sure that your pods or your nodes, whatever your compute resources, comes up safely. And there's a lot of code that we put in behind the scenes, a lot of edge cases that we cover that come up with these stages. So a blue-green for us is hundreds, if not thousands, of lines of code of years of us doing blue-greens at Netflix and Google and in production with those companies that you saw earlier. Right, so what you're getting is a lot of the best practices and learnings, and you having to avoid all those errors and problems that we've already ran into. All right, so applications, pipelines, and stages. So this is the view inside of Spinnaker. Upper left-hand corner, you have your application name. This application name is called commits. On the left-hand side, you're able to kind of filter your pipelines based on whether they're running, their terminal, succeeded, a few different parameters there. It shows you all of the pipelines that it takes to get code into production. Because what we don't want is just this one giant pipeline that contains everything from dev into production. It'll become very messy, unwieldy, hard to understand. We want more atomic pipelines to be able to go into particular environments. As you click into each one, you can see what those pipelines are comprised of, and we'll get into that here in a second. But overall, these are the pipelines that we have. It tells you also the environments or the accounts that you're deploying into. Right? So Spinnaker is all about giving you a lot of context about what is happening. It's not trying to control you, but it's trying to tell you more about what is going to happen or what has happened in the past. There are the stages too. So we have a drop-down for all of the available stages. There's a bunch that comes from the community, the ones that are community supported. But this doesn't stop you from extending Spinnaker to do it on your own. So you can create your own stages that are available for your company and the needs of your company, so that way you can customize what each stage does. So to get started, we're going to configure a Jenkins master so that we can actually connect to the existing cluster. We use Valueadd, a tool that we've created to easily help you configure Spinnaker so you don't have to go do it on your own. And this is all it takes to actually add a Jenkins master into Spinnaker. You give it the URL, a username, a password, and then you apply it to Spinnaker. Spinnaker will then pick up that credentials and then actually go connect to Jenkins. From there, we'll start actually creating our pipeline. We'll start off with a trigger. Now, as I was mentioning earlier, those are the available triggers that we have: webhooks, pub subs. We can connect into Jenkins, a Docker registry. Here we're connecting to Jenkins, and what this means is once the Jenkins job is completed, it will trigger this pipeline. So what we're looking for is a CI job to be completed so that we can start the CD process. It's important to know that Spinnaker really focuses more on just the entire SELC, but doesn't necessarily mean that it's going to be doing the actual CI. It's not going to be doing the actual security. It's actually just gluing all of these pieces together, and in this case, it's Jenkins. So we select our master. We can configure multiple masters, and then we're finding the job that we're looking to execute from or waiting for it to complete. The property file at the end is a way for our Jenkins job to actually send us data into this pipeline. So good things to pass are things like a git hash, a build number, maybe a flag to tell it to do canarying or not to do canarying, depending on the type of application. But this is a way for Jenkins to communicate with Spinnaker and for you to use those variables further downstream. All right, so we can set up Jenkins as a trigger. We can also set up Jenkins as a stage. By the way, the reason these are GIFs is because I'm not brave enough to do like a live demo. We could barely get the laptop stuff working, so this is a lot safer for me. So here's a stage. A stage for us and is very similar to the trigger, right? We can go to a master. We can kick off a job. And what we're going to do is pass in values into that job. So in this case, let's see what I'm doing here. I'm looking for a particular parameter that comes out of our context. I'm going to wait for that to finish. Finish as it go. All right, I think we're going to pass the build number. So we're passing the build number from the trigger into this next job. And so that value will be passed in. We can pass any number of variables and anything that we want from a previous trigger into this or a particular stage into this job. We're selecting the job. And again, we're waiting for the property file. The property file will allow us to collect output from the Jenkins job. So if you archive a property file as a Jenkins job, we will be able to pull values out of it, whether it's JSON or a key value pair. Oh, actually, a couple more parameters down there. If you see the wait for results and what to do if the build is unstable, right? So there's this notion of an unstable build in Jenkins. So you're able to actually set up parameters based on that. And waiting for results is we can actually just kick a job off and let the pipeline continue going. 99% of the time, you're going to want to wait for results. But if you want to do something asynchronously and let that job run and continue the pipeline, you can do that as well. Next, we have this notion of a manual judgment. The manual judgment in this, in here, is really accounts for, if you all remember at the very beginning, we had a PM approval, we had operations approval, dev approval, everybody wants to approve. So this manual judgment allows us to essentially take in human input into our pipeline, right? So we don't have another process outside of this. You know, and back to the story at the very beginning, when I first tried to uncover how code got into production, what they were doing was actually getting the approvals from PMs and operations and developers in meetings and using spreadsheets. And so the way that they were managing their deployments was actually through spreadsheets, was determining what would go out into production. And once that cell turned green because somebody approved it, then they would go push the button on Jenkins. And I think we're a lot better than deployment through spreadsheets. And I think we have the tooling today to do that. And it's really important for us to kind of, we as an industry, to move people towards automation. Because I think it makes our industry look better and feel better, and it actually produces greater results than to continuing to do things in spreadsheets. So this allows us to get out of meetings, right? Because now the approval is just waiting. The pipeline will stop, until you get the approval of the people that need to be approved. And then there's a lot of compliance use cases that require us to have approvals from somebody else than the person who started the pipeline. So in this case here, I'm just setting up some instructions. You could say, hey, go to this website, maybe insert some results here, and allows you to set up multiple options that give feedback into the system. So in this case, let's do it. Nope, too scared. Let's not deploy. So the next step here is I'm calling another Jenkins job, but I'm using deployment windows to allow us to not deploy on days that we don't want to. I know, for one, I don't want to see deployments at 5 o'clock on a Friday because I enjoy my weekends. I have kids. I want to spend my time with them. I don't want to be firefighting production on a Saturday morning. And so what we've done here is set up a deployment window. Now, for this particular company, because they only deploy on Tuesdays from 9 to 3, we can actually say, all right, finish everything in the pipeline. The pipeline will stop and hold and wait for deployments on Tuesday from 9 to 3. The moment that 9 a.m. Time hits, the pipeline will continue. And that way you can have everything ready. It's not a surprise on Monday. It's not a scramble on Monday. You can actually get everything ready to go to production, and all we're doing is waiting for Tuesday for the pipeline to continue. So we also have a system inside of Spinnaker that we call Cayenta. Its primary use case is canarying, but we can actually use the engine for verifying deployments, not only as a phased rollout, but also just to compare today's metrics with yesterday's metrics, or this hour's metrics with another hour's metrics. The engine is a statistical engine. We've learned over a period of time that doing things with machine learning on canarying actually yields to really bad results. It's hard to debug. This is what we've learned doing this at Google and Netflix at scale. So we've regressed back into just a standard statistical engine. That way we can actually detect what's wrong and then tell you what's wrong very specifically and allow you to control it a lot more than you could with just a kind of a black box model. So when we do this, we're defining what are the metrics that we actually care to look at. And so in this case, memory, you can see the name is memory usage. A fail on, increase or decrease, or either. So for example, we might not want to alert whether the CPU is going down. That might be something that you want. And a few other parameters there that we can add. We can weight the different parameters. So for example, if it's an API, we might want to actually weight heavier on CPU. And this engine then from here allows us to configure it into the pipeline. So we configured this profile. This profile allows us to kind of reuse it. So for any service that has a particular profile that looks like an API, is that type of archetype, you might want to use the same profile instead of having to redefine them over and over and over again. So here we're taking that profile and we're defining our canary analysis stage, but it's really a post-deployment verification, even though it has the word canary in there. As we scroll down, you can do a real-time analysis, which is to compare two data sets together in real time. Ultimately, the retrospective is if you want to compare two older periods of times. We selected our config name, Datadog, how long we want this analysis to run for. That's totally dependent on your application. How much data does it get? If you have an application that doesn't get very much data, you're going to need to run it for a lot longer to get a lot more sample sizes. The interval, how often that we're going to check. The step size is really just the aggregation size. And then the last one, which is the look back window. And this is really important. This is what you want to see, is you're going to see if my deployment today looks like the one that looked like yesterday. And if it looks the same, great. If the metrics are different and they look different, then we're going to fail the pipeline. And what's great about this is that you don't have to actually define your bounds. You don't have to know what good is. You just define that the assumption is that yesterday was a good day, and today might be a bad or good day depending on your deployment. So this is what the final pipeline looks like. We do a manual judgment. We then move on to call Jenkins to update the chef server. We wait for those deployment windows. The next one is also we apply the chef cookbook. This, again, is another call to Jenkins. And then we do an automated verification. And so here we're depending a lot on Jenkins to be able to do a lot of the work that it's always been doing, but we're just adding a bunch of goodness to it. So getting out of meetings by adding manual judgments, adding deployment windows to add safety so that people don't deploy late on a Friday, and then automatic verification. So here's what it looks like when we execute the pipeline. We're going to give it a build. Since I didn't want to wait for the actual build from Jenkins to kick it off, we'll select build 36. That data that you saw there came straight from Jenkins. We'll select yes, continue on with the pipeline. We'll wait for Jenkins to update the Chef server. As this is happening, we get real-time information of what's happening inside of Jenkins. So here we're waiting for that deployment window. This is what it looks like. Now, one of the philosophies of Spinnaker is that we give you guardrails, not gates. So we're not going to stop you necessarily from pushing forward. If it's an emergency and you need to deploy outside of your deploy window, we'll let you override it. I didn't want to wait till Tuesday, so I clicked the override button, and it allowed me to push forward. So here we're skipping that execution window again. And you're able to see the task status. I waited for it to start, waiting for the job so basically waiting for a thread to be available in Jenkins. It gives me the link back over to Jenkins so I can see what's happening. Looks like the console window tells me that everything's complete, and then the job will move on into the next stage. Here again, just more information on the Jenkins being completed, and then we've begun our canary analysis. And now you notice our score shows that we've been doing well. We're able to dig in because it is a statistical engine. We're able to see exactly where do we pass and fail, and we're able to compare those two results. So we're actually comparing real data over a period of time and using an algorithm to determine what different or what bad looks like. And the last thing that Spinnaker provides, which is different, is an application-centric point of view. Right? So we're here to really add value to developers' lives. And developers care about applications. They don't care about the infrastructure. They care about their applications. So in a world where there's tens of thousands of applications, I care about mine, and so I want to see the errors and the problems and the infrastructure for mine. So we aggregate the views across dev, stage, and prod so you can see the state of your application across all the environments. You're able to pull up logs. You're able to really kind of check out what's happening in production. So in this last 20 minutes, what have we done? So we've automated those manual handoffs by having those manual judgments injected into the pipeline. We've also automated deployment verification. That step that happens after you push something into production to check the metrics or the logs. So that's also automated. We've added deployment windows for safety so you don't have developers deploying things at 5 p.m. on a Friday. And then we're able to visualize our infrastructure just for our applications so that we don't have to bounce around 10 different AWS console views and regions and accounts. And this is what makes Jenkins and Spinnaker so awesome together, right? All of your logic on getting a deployment done is already in Jenkins. What you need is a lot more SDLC goodness to really kind of supercharge your deployments. And if you want to get started, go to spinnaker.io. That's where the community pages are. We have a lot of great documentation on how to get started with Spinnaker, how to deploy to whatever infrastructure you're using today. We support all of the major clouds and infrastructure. So thank you.
Challenge? So we have multiple production environments in multiple AWS, Azure, across the globe and everything else like that. And they're all very siloed for compliance reasons. We can't do pushes, but we can do pulls. So what I'm wondering is that something that Spinnaker even supports?
Oh. So it doesn't support pulls that what it really does is it integrates with the infrastructure APIs. And that's how we ultimately do deployments. I will say though, I've not run into a compliance rule that states the pushes versus pull. Yeah, and so one of the things that we also help with in doing these exercises, what we really try to uncover is there's compliance and regulation there. And those are actually, in a lot of cases, interpreted in a lot of different ways, and every company interprets the exact same wording in a very, very different way. And what I found is actually that the way that they're interpreted is typically in the most risk-averse way, which is like, I'm going to read this word, and I'm going to say, well, actually nobody can have access to production except maybe you, right? But that's not what it says. It really, most of it, what it comes down to is just having an audit trail. So it didn't say who can and cannot have access to. In fact, you can give every engineer access to production. There's no compliance rule against that. It's just more of what are the audit trails? How do you prove that somebody that did have access to production didn't change something inadvertently? And then again, it comes back to auditing. So I'm not sure that we'd be able to help on the push versus pull, but typically we come in and work with the compliance overall.
Okay. Any other challenges there? Okay. Anybody else have any other challenges? Okay, here comes one.
So currently we actually just use Jenkins, and we already have this problem, like users don't understand what we are doing, right? And migration is always hard. Like, imagine if the user are seeing this whole dashboard and let them start to actually build their pipeline themselves. Or I would say, I mean, it might be easier for them, like it's a UI now. Like, although for Jenkins, in our company, we actually have like a Jenkins file and then let them change the Jenkins file, update that. But most of the users, like, they don't want to do it because they don't really understand the tool. So I guess for this one, my question is, how do you actually overcome this? Like, the user still, they don't understand the whole maybe not the whole picture. Like, they only know the development part, but not really the whole flow. So how do you educate users and make them feel like confident? I want to do this because it makes my life much easier. And I guess documentation is great. I mean, if you have great documentation, it's easier, but still, sometimes, like, based on my personal experience, if the documentation is too long and there's something I don't understand, I don't feel the confidence, right? So I want to learn, like, based on your experience, how do you actually make this transition smooth and let the user actually feel confident when they migrate?
Let me ask you first a question. In your organization, are the developers responsible for their own operations and software delivery pipelines, or is somebody else responsible for that?
It's actually complicated. Like, sometimes, I actually don't know. I support them, but I feel like sometimes QA are responsible for their Jenkins file, and sometimes it's developer. And yeah, we do a lot of.
Oh,
yeah.
sorry.
That's what I want to figure out. Do they actually want the file, like a YAML file or Jenkins file, or do they actually like this kind of UI stuff? Like, but still, like, although I know pipeline, to me it's kind of overwhelming at the beginning when I see so many options, like how to understand each part and how to make it right when I do make the pipeline. Yeah.
So I'm going to answer it in two parts. So the very first part is what we've seen going into organizations with Spinnaker is that when your teams, when the developers are not, like, and it's clear, right? It has to, it has to be clear that they're responsible for operations, pipelines, QA, all of it for their own services. The reason I say that's really important is because there's no incentivization to learn. You can make it as easy as possible, but if it's not my responsibility for doing deployments and I'm not getting incentivized to do it or being accountable for it, I don't really care if I'm a developer. And so that's what we've seen. And so what ends up happening is we go in with organizations and they've asked us to do this kind of work before. And it's really trying to push somebody to do something that they're not motivated to do. And so what ends up needing to happen is you have to go up to VP or CTO level and say, no, developers are owning this. So if you look inside of Netflix or Google or Amazon, they are all responsible for how their own code gets into production. So they're constantly incentivized to look for the easiest way to get to production. I'm incentivized to learn your tooling because learning your tooling, even if may not be the best, it's still better than me starting from scratch. So that's like the very first thing that we've seen, and going into these organizations, we can teach them all we want, but if they don't really care to do it, they're not going to do it. The follow-up to that is the best way that we've seen to do it is to templatize things and to try to abstract out as much as you can from them having to know it. So we have a tool that allows you, so you saw the UI, all of that is actually backed by JSON or YAML, right? And then from there, you can start building templating tools so that you can abstract out all the complexity from it. So if you have a complex deployment orchestration into multiple accounts, multiple regions, you can just, you as a central team owner can own that complexity and expose it to them as like a flag or something like that, just says multi-region, multi-account, right? And then you handle the complexity, and they'll get all of that pipeline by using your template, your core template. So if you've used something like Terraform, it's kind of like that, modules, things like that.
Yep. All right. We'll move on to our next area here. What successes have you had in this area? Anybody want to talk about successes they've had? Just kind of say, as a follow-on to this, talking, in general, very much agreeing with what you were saying there. Yeah, at Microsoft, we talk about feature teams. And the feature team owns the features they're working on. They own the pipelines that they're building. They own the applications running in production. So they're very much then incentivized, because you build it, you have to support it, even to the point of every sprint, somebody from that feature team is responsible for monitoring production and watching for issues popping up and that. So, if you have to support something that you wrote in production and you found that, oh, gee, I guess I kind of cut corners last time, next time I'm going to take the extra time to make sure that I'm not getting the call at 2 o'clock in the morning to go support that. Yeah, it gets everybody... everybody's then thinking towards all of the goals around, okay, how do we support this in production? How do we make sure we've got the performance that we need and everything? It's not just, well, I coded it, now it's somebody else's responsibility. So yeah, and that's very common in the industry. It's not just something that we came up with. Like you said, Netflix, Google, others, there's a lot of information out there about feature teams and, how do you build these teams and how do you, really get into product thinking. It's not just a project that I work on and hand off to somebody else, but I own that product cradle to grave, or the team, I should say, owns that product cradle to grave. So, anybody else want to talk about successes? Spinnaker, Jenkins?
I think to your point about having successes and transformation, or you're trying to get people to do to move to a different pipeline or things, has been sort of like saying to teams, your value add as a product team is not building your own pipeline. That doesn't give new value to them, to your external customers. And why would you want to reinvent the flat tire? So sort of just have them say, we're supporting them. You can have a happy path. You don't have to do this and just plug into it. It might not be the best, but a lot of times it's just good enough for them, and they could make it 100% exactly the way they wanted it, but that means they're dedicating resources to doing that instead of the product features that the team should be concentrating on.
Just to add on that, my presentation today was about Spinnaker and Jenkins, and I think it's really important that it's really not about the tools. It's about getting to a particular outcome. And I see so many core development teams just want to start from scratch and throw away everything they did with Jenkins and maybe start all scratch with Spinnaker. And the reason I give this talk is to show you there's a transition. And it doesn't have to be Spinnaker. You can use another tool. You can build your own tool. But whatever it is, it's iterate, because there's no value in these tools in and of themselves, right? So the more time you spend in these tools, the less time you're delivering value, like you just said. And that's really, really, really important, that we got to remember that we're hired by these companies to deliver value, not to build tools. And so there's an iterative process. And in this, my presentation is meant to say, here's an iterative process to a better place. So if you're going to a new piece of infrastructure,
take some of the stuff you have. It may not be perfect, like you said. How do you make it better over time? Because you don't want to spend the next 2 years just rebuilding a tool or getting yourself to a new flat tire. So I really like what you said. That was really good.
I was going to say one other thing on successes, and that one of the things we do too is with dashboards. Building out dashboards where you can there's different widgets and things where you can visualize the status of the pipelines. How long are they taking? Are they, I deployed to development, all my tests passed, it deploys to QA, but wait, some of those tests failed. Is it okay to move forward with a few failed tests or not? But making that visible, through the various tools, whether it's these tools or working with other tools to do that as well. Okay.
So there was several talks that have been about sort of value stream mapping and saying where are the wait times and things. And so if you have the manual piece, you can sit there and actually get the stats out of how long you're actually waiting for approval from Bob or whatever it is. And so you start collecting those data, that data that you can say, well, it's Bob's fault. I mean, if you will, but it's saying where's the bottleneck of things like that. So the first place is, as it was said before, is you have to figure out your baseline and then start looking at those things. And the visualization piece in Spinnaker is one thing that I think should be stressed more, because people don't. It shows you what the pipeline is, and that's a lot of people. It's hard to grasp, or people aren't very good at drawing. So it's a standard way to look at the pipelines.
Okay. Any other comments on successes? Okay. So the next thing was, if you had that magic wand, what would you like to see in this area in the next 2 to 5 years? All right. Miles?
Well, I can't wait for everything to have an API. That's probably one of the things that makes automation challenging right now, is when you have to deal with those few legacy components that don't have any kind of an API, and you end up doing a lot of very awkward tooling around it to try and automate it. We've made progress, obviously. It gets better every year, but we're still not there yet, and there's still a lot of stuff that needs to have open, accessible APIs for us to plug this stuff into.
Anybody else? Any thoughts?
Just to add to that, reliable APIs.
Yeah. Okay.
I'll just, again, back to kind of Joe's point of rebuilding the tools. What I'm seeing is us not really getting to CD, because every time a company gets close, the infrastructure changes. We're going to Kubernetes, and then they're like, well, let's start over again. And so most companies never get to these topics that we're talking about, this nirvana. They don't get the value out of CD, because right when they're getting close, they start over from scratch again. So what I'd like to see us to do in 2 to 5 years is see more of these organizations get value out of all the topics that we're discussing here today, because right now it's just far too few. And I think it's just starting over from scratch again. So hopefully, tools that are, coming out like Spinnaker, hopefully people will adopt these kind of tools and get themselves ahead instead of starting from scratch every 2 to 5 years. And same with the API problem. Hopefully that gets solved, because that allows the ecosystem to automate a lot for us. And we're seeing a lot more of that, but you're right, it's not moving fast enough at all.
So you're continually improving on things. So I always say to people, how can I make your life suck less? It's sort of, I'm not going to make it perfect, but we can make it better, and it's an incremental thing. And then just because people will sit there and say, we did a Spinnaker, sort of demo, and people are like, oh, this is great, and this was at a meetup, and then the guy was like, I'm on an AS400. I can't do Kubernetes, but I want this stuff. So it's sort of like, taking the I guess is it's a journey, and so getting the mindset, I think, of people saying that it has to be a big bang. is the one thing I want to sit there and try to change people's mindset. It doesn't have to be a big bang. You can make a gradual evolutionary, look at evolutionary improvements as opposed to a revolutionary thing.
Yeah, and we talk about, you said make your life suck less. So, we say find what hurts the most. Where's your biggest pain point? Improve that in this sprint in some way. And then in the next sprint, is that still your biggest pain point? Do you still need to work on that some more? And then you get that piece working, and then it's like, okay, what's our next biggest pain point? Work on that. And it's a journey, right? But you can put these things for building out your pipelines and things in your backlog as well as new features, right? Because it is a journey, but when you can get to that point where you've knocked off 10, 20 of those pain points, then you can really spend more time on the new features, on the innovation. So it's definitely an investment that you're making, towards a future where it sucks less to deliver software. Now you can work on delivering great software.
One thing I want to mention is actually we're trying to figure out like a better way to just use Jenkins, because Jenkins is not good for like the CD part, right? So one hard thing is how to pick the right tool for our organization. Like I know there are a lot of options. Azure, AWS, so Google, and Spinnaker is like an open source shared community, but all the cloud providers also have their tools, right? So for me, it's like, okay, I know a little bit about this, but I never used all of them. So how do I compare? Like, I want to hear like real stories, not just a demo, but like real story. We were at this stage before we tried these tools, and then this one really fit our use case or something like that. So, but I guess we need to try ourselves probably, but yeah.
All right.
Share a
Comment
story
on that?
about that.
Yeah.
I guess it's more in line with the success kind of thing. One of the things that helped us a lot was share Jenkins libraries. So we were able to really significantly reduce the amount of like automation type of code that developers would have to write or even be aware of by providing a larger library of pre-written, functions that you can add to Jenkins, and it sure helped a lot when they could just kind of select the things that they need to do. Another one was we started to see more product teams, because we have a lot of different product teams and different sets of developers, start to adopt similar patterns when they see other teams getting their product out faster. So one of the ways that we did that was, I can't remember the name of it. There is a Jenkins plugin. Sorry, this is more Jenkins than Spinnaker, but there's a Jenkins plugin that will scan your GitHub organizations, and if it finds any new repo with a Jenkins file in its base directory, it will automatically add that as a new Jenkins project. So now we have development teams that start up new projects, and they aren't even coming to us. They're just putting in a templated Jenkins file into their Git repo, and all of a sudden they've got like some kind of base level of dev test set up, and they're starting to get results immediately. It really encourages people to start being more aware of the in-between processes after they commit to Git.
The only thing that I'll add is exactly what you said. I think it's best that you kind of do a POC on your own, because I didn't catch your name, but like Spinnaker may not be good for his environments, for Doug's environment, given his constraints and requirements. And if you were to ask him, is Spinnaker good? And he said bad, it might be bad for him, but you wouldn't know that it might be good for you. And that goes for any technology, not just Spinnaker. It'd be, spending, I think, especially with decisions like this, a week to 2 weeks just to get a feel for it is typically really good. And you'll end up, narrow the list to 2, maybe 3 technologies. Don't try 50, because there's a lot in the CICD space, but try the 3 that you think might work best and go with whatever one you choose after your analysis, and know that that's the best you could have done given the time constraints, the information that you had, the POC length, and and iterate from there. But again, I think. Just go back to his point, which is, in most cases, your biggest bottleneck is actually not the tools. It's the people and the processes that you've imposed on yourself. And the tool should almost come last, because what I'm hearing from you really is like the very first thing in order for anything to work is like changing how you actually, who's accountable for what. And that's what I spend a lot of my time on. Is actually most of the time I don't speak about Spinnaker. I speak to leaders about that because they want to talk to me about Spinnaker, and I'm like, well, we can talk about that, but like I know what the real problem is, and it's something else. So,
okay, I think we are at time, if not a little over. So, thank you very much, everybody, and we're off to lunch next.